Between the eclipsed as well as with the staggered, there is a one more intermediate conformations will be there, that is known as skew conformations. If the carbon atom is far away from your eyes, you know that carbon atom should be represented by writing the line from the circumference of the circle. If the two alkyl groups are present in the opposite end, then we say it is transformed. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Hydrocarbons. Under that, we have discussed about the physical properties of alkanes and also we have discussed about the important chemical properties of alkanes. Today, let us move on to the next topic of this unit to learn more about the conformations in alkane. Finally, we will move on to the nomenclature of alkenes, then method of preparations of alkene, and we will discuss some of the physical properties of the alkene. So, till now, whatever we have studied, it is only for alkene. In that, only thing is, we need to know about the conformations of alkanes. What is that and what does that conformation indicates in the alkane? Let us see now. If I say it as a conformations in an alkane, it is a different spatial arrangement of an atom of a molecule which can be converted into one another by the rotation of carbon-carbon single bond. So, what is the conformation? For example, if I write the ethane, that is CH3 this is the structure of the ethane molecule. So, this is a spatial arrangement of the atoms or the molecules of the compound. If you rotate to the carbon-carbon single bond, if you rotate that carbon atoms, that will known as conformation. So, what is the conformation? It is a different spatial arrangement of the atoms or the molecule in which can be converted into one another by the rotation. So, that is known as conformation. Here, I have written the example of ethane. In case of ethane, how to conform the structure of ethane? Let's see now. In ethane, there are two tetrahedral methyl groups that can be rotated around the carbon-carbon single bond to yield a several arrangement. Out of this, there are two extreme arrangement will be there, that are eclipsed form and staggered form. In this ethane molecule, you can see that there is a one CH3 group will be there and another CH3 group will be there. Is it right? Each this carbon atom, they are tetrahedral in nature because they consist of 4 hydrogen atom. Is it right? And there are two main arrangements will be there in this. It is eclipsed form and a stacked form. What is eclipsed form? Let's see now. To write the eclipsed form, I'll consider the circle, okay, where this carbon atom is having 3 hydrogen atom and another carbon atom will having, let's take another carbon atom, will having 3 hydrogen atom. So, this is a eclipsed form. Whereas, in the staggered form, this is a one carbon atom which are having 3 hydrogen atom and behind that there is a one more carbon atom which are having 3 hydrogen atom. 3 hydrogen atom. This is how we can easily represent the structure of ethane. We can easily represent the structure of ethane. So you can see that this is a one carbon atom which are having the 3 hydrogen atom. You can see this is a one carbon atom which are having 3 hydrogen atom, and there is a one more carbon atom which is present behind this, and it is known as eclipsed form. Whereas in the staggered form, this is a one carbon atom which is having 3 hydrogen. Behind this, there is a one more carbon atom which are having 3 hydrogen atom. So if you compare the eclipsed form and the staggered form, you can see that in the eclipsed form, the hydrogen atom, they are very closer to each other, whereas in the staggered form, they are far away from each other. So this is a basic thing that you must understand while studying the conformations in the alkane. So for this, I have used the example of ethane. Remember, if I talk about the ethane conformation, we know that in the ethane, there are 6 hydrogen atom will be there and 2 carbon atom will be there. And each carbon atom, they are tetrahedral in nature, which is having 4 bonds. Is it right? Yes. That is why it will form a 2 major conformation. One is eclipsed form, another one is staggered form. Always remember, for writing the eclipsed form, the carbon atom must be very closer to each other, and having hydrogen atom, they are very much closer to each other. Whereas for writing the staggered conformation, always remember one carbon atom should be front, another carbon atom should be behind that, and these 2 hydrogen atoms, they are far away from each other. So I'll explain you in detail about the eclipsed as well as with the staggered conformation. So what is the eclipsed conformation or the form? In this form, hydrogen atoms are attached to the 2 carbon atom. They are very closer to each other. For example, if you take the ethane, I have written that this is a carbon atom which are having 3 hydrogen atom, and there is a one more carbon atom which are having 3 hydrogen atom. You can see that the hydrogen atom, they are very closer to each other. Such structures are known as eclipsed structure or eclipsed form. Coming into the staggered form, in this form, the hydrogen atom of 2 carbon atom, they are oriented in such a way that they lie far away from each other. So I can write the staggered conformation also. So this is my 1 carbon atom which are having 3 hydrogen atom and one more carbon atom which is present behind to this. So in this structure you can see that this is a one more carbon atom, and behind that there is a one more carbon atom will be there, and you can see that the hydrogen atom, they are far away from each other, and they are usually 60 degree of bond angle will be present between the 2 carbon atom, whereas in case of the eclipsed form, since the hydrogen atom are very closer to each other, we cannot measure it the angle. Okay, so hope you are understood between the differences between the eclipsed form as well as in the staggered form. And these are 2 forms can be interconverted by the rotation around 600, or you can say that 60 degree about the carbon-carbon double bond or with the carbon-carbon single bond. And there is a one more conformation known as skew conformation. This is an intermediate conformation between the eclipsed form and the staggered form. Between the eclipsed as well as with the staggered, there is a one more intermediate conformations will be there, that is known as skew conformations. So there are how many conformations will be there? There are of 3 types. So first one is the eclipsed form, where the between the 2 carbon atom, hydrogen atoms are very closer to each other. Whereas in the staggered form, we have understood that between the 2 carbon atom, whatever the hydrogen is there, they are far away from each other. Whereas in the skew conformation, remember, this is an intermediate conformations which is exist between the eclipsed form as well as in the staggered form. The staggered conformation of the ethane are more stable than other conformation because in this energy is associated is minimum and the repulsive interaction between the hydrogen atom they are attracted towards the carbon atom are minimum due to the maximum distances between them. I shall write a structure of three, that is a skew and the staggered as well as with the eclipsed form. This is the eclipsed structure and staggered conformation. And skew conformation. So here I have written the three structure, that is eclipse, stagger as well as with the skew conformation. In all this conformation, I have said that the staggered conformation is more stable. How does? You can see in the staggered conformation between the two carbon atom, whatever the 6 hydrogen is there, they are far away from each other and there is no much attraction between the two hydrogen atom. Since they are far away from each other, they are very stable. Whereas in case of skew as well as in the eclipsed form, the hydrogen atoms are very closer to each other. They are very much repulsive in nature because we know that hydrogen atom which carries the plus charge. So because of the hydrogen atom are very closer to each other, they repel with each other also. That is why the staggered conformation is more stable than the eclipsed one, and between these two always remember the skew conformations will be exist. Okay, that is why the order of stability of the ethane will be staggered, skew and the eclipsed. Staggered is more stable than the skew and skew is more stable than the eclipsed one. And while understanding this conformations of the ethane, we use some of the common terminology. What are those? Let's see now. The first one is torsional angle. So what does it mean? It is the angle of rotation about the carbon-carbon bond and it is known as torsional angle. Already I have explained that between the two carbon atom, if you rotate it, it gives rise to the skew conformation. Such rotations are also known as torsional angle rotation. And coming into the torsional strain, it is a repulsive attraction between the electron cloud which can affect to the stability of conformations. They are known as torsional strain and the magnitude of torsional strain depends upon the angle of rotation. We know that in the ethane, the 2 carbon atom will be there and having 6 hydrogen atom. So if any one of the carbon atom, which are attracted towards the hydrogen atom because of its electron cloud, such rotations will lead into the formation of torsional strain. And next, coming into the torsional energy, the energy which is required for the ethane molecule to rotate about carbon-carbon single bond, they are known as torsional energy. So this is how torsional energy, torsional strain and torsional angle can be commonly used while doing the conformations of alkanes. So hope you all understood with the conformations of ethane where it exists in the two major structure, that is in eclipsed form as well as in a staggered form. Always remember, if I say it is the eclipsed form, 2 carbon must be there having a 6 hydrogen atom and they are very closer to each other. When I talk about the staggered conformation, remember in this structure also there are 2 carbon atom will be there, but all 6 hydrogen atom, they are far away from each other. Between the eclipsed as well as with the staggered, there is a one more conformation called as skew conformation, which is also known as intermediate conformation. And next one is, whereas in the conformations of the alkane, we can represent this into the two way. The first one is Newman projection formulae, which is also known as 2D representation, and there is a one more representation known as Skew-Horse formulae, which is also known as 3D representation. Let's see what is a Newman projection formula or the 2D representation. In this method, the carbon atom, which is very nearer to our eyes, and the groups are attached to it, are represented from the center of the circle and the line attached to the center. Whereas the distinct carbon atom having the groups attached to are represented by the circle and the lines attached to the circumference. So already I have explained that by writing the structure of ethane in an eclipsed form as well as in a staggered form. So remember, if the carbon atoms are very near to us, we need to represent it by writing the circle where the carbon atom will be having 3 hydrogen atoms in case of ethane. If the carbon atom is far away from your eyes, you know that carbon atom should be represented by writing the line from the circumference of the circle, so that to represent with the 3 hydrogen atom attached with the another carbon atom. That forms an eclipsed form, and similarly for the staggered form. Such conformations or such representations of the groups attached to the carbon atom in a 2D way, they are known as Newman projection formula. Always remember, while writing the Newman projection formula, we will consider the carbon atom which is very near to us. That can be written by writing the circle. At the center, there is a 1 carbon atom attached with the substrate group, attached with the 3 hydrogen atom, we can see. Okay. Whereas the carbon atom which is very far away from our eyes, that can be represented by writing the line from the circumference of the circle to indicate the remaining hydrogen atom. Whereas in the Skew-Horse formula, that is in a 3D structure, in this form, the front carbon atom will be shown at the lower end of the lines, while the rear carbon atom at the upper end. And the 3 lines attached to each carbon atom are represented by the 3 hydrogen atom, and the bond angle will be around 120 degree. Here you can see that this is an eclipsed form of ethane and a staggered form of ethane, which I have written in the staggered conformation. How to write this? Always remember, for writing this Skew-Horse formulae, we need to consider the carbon atom which is very near to our eyes, and we need to represent it at the lower end. If the carbon atom are far away from our eyes, that has to be represented at the upper end. Okay. So, which consists of 3 hydrogen atom and 3 hydrogen atom. Similarly, in the staggered conformation, the carbon atom which is very closer to our eyes should be written at the lower end, and carbon atom which is very far away from our eyes should be written in the upper end. This is how we can represent the conformations of the ethane by writing the Newman projection formula and the Skew-Horse projection formula. So, hope you all understood with this. Now, let us understand with the alkenes. We all know that alkenes are also unsaturated aliphatic hydrocarbon, but between the 2 carbon atom, there must be a 1 double bond between the aliphatic carbon atom. Then we say it is alkene. We all know that what is the general formula to represent the alkene, that is CnH2n. And these alkenes are generally known as olefins because when it is react with chlorine, it will form a oily product. That is why the alkene, which is also known as olefins, they are also known as what? Olefins. Okay. Let us see with the nomenclature, how do we name this alkene? Let us understand. Okay. So the first members of this alkene is ethene, where the molecular formula will be, or structural formula will be goes like this: CH2 double bond CH2. You can see that there are only 2 carbon atom will be there, and between the 2 carbon atom there is a 1 double bond which is there. Hence, the root word for the 2 carbon atom is eth, and we know that the alkene should be end with ene, which is a suffix. Is it right? So, it should be ethene. Okay. Next is, there are 3 carbon atom will be there, and numbering will be goes like this, because the carbon atom which are having a double bond, which has to get the least number. Is it right? So, it is propene, or 1 propene you can say. Next is 1, 2, 3, 4. 4 carbon atom will be there. So, it is butene. To which carbon atom it is there? Double bond to the first carbon atom. So, it is 1 butene or but1ene. Okay. Similarly, for next carbon atom, you can see that there are again 4 carbon atom will be there, but there is a double bond between the second carbon atom and to the third carbon atom. Is it right? Hence, it is named as 2-butene or but2ene. So, there are 3 carbon atoms will be there, and there is a 1 alkyl group attached to the second carbon atom. Is it right? So, it is 2-methyl propene. It is 2-methyl propene. This is how we can easily understand the nomenclature of alkene. It is very simple. Remember, while naming this alkene, the suffix should be end with ene, and while numbering the carbon atom which is having a double bond, that has to get the least number. So, hope you all understood with the nomenclature. Next is method of preparation. So, the first method is from alkynes. By using alkyne, how do we prepare the alkene? Let's see now. Alkynes on partial reduction with hydrogen in presence of Linda's catalyst, that is palladium, is supported over the calcium carbonate, which is deactivated with the quinoline or with the sulfur to give cis-alkene. To give what? Cis-alkene. So, here I have considered the alkyne. You can see that between the 2 carbon atom, there is a triple bond. Is it right? Between the 2 carbon atom, there is a triple bond. Hence, it is named as alkyne, which is allowed to react with hydrogen gas in presence of Linda's catalyst. What does it mean? Here, we have considered the palladium, which is supported with calcium carbonate, that is known as Linda's catalyst, to form cis-alkene. So, what is that cis-alkene in the sense? If you write the carbon-carbon double bond, and if any substrate groups are there, if it is present at the same side, if the 2 substrate groups, or you can say that if 2 alkyl groups are present in same side, it is said to be cis form. If it is present in the opposite side, then we say it is trans form. It is trans form. You can see that if 2 alkyl groups are present at the one side, then we say it is cis form. If the 2 alkyl groups are present in the opposite end, then we say it is trans form. So, while taking the alkyne, if you react with hydrogen gas, you will get cis-alkene, where the 2 alkyl groups are present at same side. Hence, it is named as cis-alkene. So, this is my general reaction. Let us take one example for this. So have consider ethane, which is allowed to react with hydrogen in presence of palladium supported with calcium carbonate, which is a Linde's catalyst. It will give cis alkene. Okay. Similarly, you can take propane, which is allowed to react with hydrogen gas in presence of Linde's catalyst. It gives rise to the propene. This is how, by using the alkyne, we can easily prepare the alkene. Okay. Next is, already I have used the Linde's catalyst to prepare the alkenes from alkane. Suppose if I change my solvent, that is alkynes, when it is reduced with sodium in presence of liquid ammonia. So the same reactions will be given rise to the trans-alkene. How does? Here I have considered the ethane, which is allowed to react with hydrogen gas in presence of sodium supported with liquid ammonia. You can see that the two alkyl groups are present in the opposite sides to give a trans-alkene. Only by changing the Linde's catalyst with the sodium, which is supported with the liquid ammonia, you will get a trans-alkene. This is how we can prepare the cis-alkene or trans-alkene by using a different catalyst and also by using the alkynes. Next is from alkyl halide. So what is the alkyl halide? We know that if the alkyl group, which consists of any one of the halogen group, then we say it is alkyl halide. By using that alkyl halide, how do we prepare the alkene? Let's see now. When alkyl halide are heated with alcoholic potash, dehydrohalogenation takes place and gives rise to the alkene, and this reaction, the hydrogen is removed from the beta carbon atom, hence this is also known as beta elimination reaction. So alcoholic potash, in this sense, we know that the potassium hydroxide can be prepared by dissolving in alcohol. Okay. If I dissolve the potassium hydroxide in water, then you say it is aqueous potash. Okay. If it is dissolved in alcohol, we say it is alcoholic potash. Okay. Here I have considered the alkyl halide. This is my one alkyl group and this is my another alkyl group, but one of the hydrogen is replaced with alkyl group. Is it right? Yes. This alkyl group may be chloro, bromo and iodo, which is upon treatment with alcoholic potash, it gives rise to the alkene. How does it forms an alkene? Only because this hydrogen atom will forms a bond which gives rise to the bond to the carbon-carbon single bond, and this halogen atom will be get eliminated and forms a alkene. This is how you can prepare the alkene by using alkyl halide, and this kind of reactions are also known as beta elimination. How does? We know that this is a alpha carbon atom and this is a beta carbon atom. In the beta carbon atom, we are removing one more hydrogen atom to form a double bond between the carbon-carbon atom. Because of this hydrogen atom which is eliminated from the beta carbon atom, which is said to be beta elimination reaction. So, hope you all understood with this reaction. And this process, which is also known as halogenation, dehydrohalogenation. What does it mean? Dehydrohalogenation, in the sense, it is a process of removal of halogen group. That is why to remove this hydrogen atom, I put a double bond between the carbon atom and also halogen will be removed. Since we are removing the halogen group from the alkyl halide, it is also known as dehydrohalogenation. So this is one of the important process and it can be asked for 2 marks. How do we prepare the alkene? By using alkyl halide, and why it is known as dehydrohalogenations or beta elimination can be asked for 2 marks. And the halogenation follows the order of tertiary alkyl halide, secondary alkyl halide and primary alkyl halide, and rate of the reaction will be varies with the different halogen. That is, with the iodo is more reactive than bromo, bromo is more reactive than chlorine. Okay, this is how we can easily form the alkene by using alkyl halide. I can write one more example for this, that is CH3 CH2 iodo I'll take in presence of alcoholic potash. What does it forms? This hydrogen will goes to the bond and iodine will be get eliminated because it is an halogen. It forms alkene. This is ethene. Okay, this is how we can prepare the alkene. Next is from vicinal dihalide. Vicinous in the sense adjacent. Dihalide in the sense, in the following example, we have used the two alkyl group. They are vicinal to each other, which means to say that they are very adjacent to each other. If you consider the halogen group, if it is present on the both the side, then you say it is vicinal dihalides. Vicinal dihalides in the sense, two halogen atom attached to the two adjacent carbon atom react with zinc to form a alkene, and dehalogenations reactions will be taking place. Here you can see that I have a two carbon atom which are having two halogen group. They are very adjacent to each other. When it is react with zinc metal, it involves the elimination of halogen group to form a alkene. Okay, how does this halogen group will be get eliminated? Because it react with the zinc metal and forms a zinc bromide. This process, which is also known as dehalogenation, because the halogen group will be get eliminated. Similarly, you can take CH3, CH, CH2, Br and Br. You can see that these two are the adjacent carbon atom which are having two adjacent halogen group. Hence, it is known as vicinal halogens or vicinal dihalogens, we can say. What does react with zinc metal? This halogen atom will be get reacted with the zinc metal to form zinc bromide, and it forms a double bond between the first two carbon atom to form a alkene, and this is propene, or you can say it is 1-propene, and name of this is ethene. This is how by using vicinal dihalides also we can prepare the alkene. Next is from alcohols. How do we prepare an alkene? By using alcohol. Let's see now. When alcohols are heated with concentrated sulfuric acid, they undergo dehydration to give alkene. These reactions are also known as beta elimination, because here I have considered the alkene which are having OH group. Okay, so this is an alcohol. Okay, when it is react with concentrated H2SO4, it eliminates the OH group and it eliminates this OH along with one of the hydrogen and forms the water, and there is a formation of double bond between the carbon atom and results in a formation of alkene. Similarly, you can write ethanol structure like this. The ethanol, okay, the CH3, CH2, OH. What will happen? This OH and H will form a bond and results in a formation of water molecule. As a result of this, it will form a double bond between the carbon atom. It is known as ethane. Since you are removing the hydrogen atom from the beta carbon atom, hence it is also known as beta elimination reaction. So, hope you are understood with the preparation of alkene. So, there are different ways to prepare the alkene. So now let us see with the physical properties of the alkenes. So the first 3 members are gases, next 14 are liquids and higher ones are solid. When we talk about the alkenes, the first 3 members, that is from carbon 1 to carbon 3, they are gases. Carbon 14, from 4 to 14, they are liquids. Above 14, they are solid in nature. And ethene is a colorless gas which gives to a faint sweet smell, and all other alkenes are colorless, odorless, and they are insoluble in water, but it is fairly soluble in organic solvent, that is benzene, petroleum, ether, etc. And the boiling points of alkene are increases with increase in the molecular masses. N-alkenes have a higher boiling point than the branched alkene. Why is it so? Because when the branching which has happened in the carbon chain, their boiling point will be decreases. As the number of carbon atom which is increases in the length, due to their increasing in the molecular masses, their boiling point will be increased. So these are the 3 important physical properties of the alkene. In the next class, we are going to understand with the chemical properties of the alkene. Okay. So by this, I like to say that, so today in this session, we learnt about the alkenes, method of preparation, nomenclature, physical property. So what are all the things which I have taught in the session? Again, it is very important for the examination point of view. Have a look on it. Try to work on. We'll meet you in the next session. Till then, take care. Be safe. Thank you.